Hi everyone. Today we're going to introduce the tuning fork lab. And the tuning fork lab is kind of a big lab. You ask anybody that's been through pre-calc, they're going to remember the tuning fork lab. It's a pretty intense lab. I think I wanted to go ahead and introduce what the process is so that you have that going in, so that you have more time in class to work. Goal number one is to find the equation of a sound wave created by a tuning fork. We've been finding the equations of nice sine graphs that are all nice textbooky kind of equations. We're going to use what we've learned with those to kind of apply to something more real world. So a sound wave is an example of a sine wave, and we're going to create this nice, beautiful sound wave by using a tuning fork. I could sing, but that probably wouldn't be a beautiful sine wave, so we'll use a tuning fork and it'll give us this perfect sine wave. And I say perfect, it's not perfect like we're used to. It's not going to have nice axes of, pi and 2 pi, 3 pi. It's not going to have a nice y-axis of 1, 2, 3, 4. We're going to be using a lot of decimals. So grab your calculator. I don't know if we need it or not. I'm just introducing it, but let's jump in. Let's see what it's going to look like. As you'll recall from our previous homework assignment, I would give you a sine wave, and then you'd have to look at it, determine the amplitude, period, phase shift, vertical displacement, turn those into an A, B, C, and D to write the equation. So that's what we're doing. Now, I'm going to do one here that does not look like the ones we're doing, because if you look at your axes, it's not scaled by pi, 2 pi. It's still not a terrible scale. I promise the one you get is going to, instead of having like 1, 2, 3, 4, 5, your scale is probably going to be like, you're going to come across numbers like 0.0127 and 1.394. So some super ugly decimals. But let's get the gist of it here so that you can do it with those ugly decimals. The process is the same. All right, so let's start off and let's look at amplitude. When you look at this graph, and you may want to take some notes here, not gonna lie, might be nice. You might be the favorite partner in your group tomorrow. The amplitude, remember by definition, that is half the distance between your min and max. That's what it is. Now, we always think of it as just how high or how low it goes, but that's when it's on when it's centered over the x-axis and it hits nicely. So really we have to go back to the definition here. Half the distance between the min and the max. If you look at our graph here, I could find a min and I could find a max. Here's a nice minimum. Here's a nice maximum. Could you find the distance between those 2 points? Ignore the scale for right now. Could you find the distance? And then take half of it? All right, so the first question that we're always going to ask ourselves is this an X kind of thing? Is this a horizontal concern or is this a vertical concern? Are we looking at X values or Y values? Because what I'm going to do is I'm going to be tracing this graph that we have. And ultimately, it is a scatter plot of data points collected from this tuning fork sound. But it's a bajillion data points, but it will always, because of the way it is, it's collecting all these data points and then connecting them, which makes it look like this nice wave, but it'll always be able to get me mins and maxes. Any other point, I can't guarantee. It might hop over other points that I wish I could get, but like maybe if I wanted an x-intercept or something, it's not going to guarantee that it's going to land there. I will always have a min and max though. So I'm going to base everything I do today off the ability to get peaks and valley and get those ordered pairs. So I could go trace this and get that ordered pair, and I could get this ordered pair. So assuming I could do that, how do you think you would find the amplitude? Or I'm sorry, let's make it even simpler. How are you going to find the distance? All right, so let me ask you some questions in the ed puzzle. First of all, when I'm dealing with amplitude, is that an X thing that I'm concerned about, or is that going to be more of a Y value thing that I'm concerned about? All right, it should be a y value. Amplitude is talking about what's going on vertically. That's a y value. So I'm going to be looking at the y values, not the x values. So looking at the second number on those ordered pairs. Now, what would you do if I knew those two ordered pairs? How do you find the distance between two things? And I'm not thinking distance formula. I'm only working with the y's here. If I knew this y and I knew that y, how would you find the distance between them? Okay, now let me ask you again. Let's see. Let me throw some numbers in. Let's say I knew this y value. Again, I'm ignoring the scale. Let's pretend that I knew that this y value was 15 and I knew this y value was 9. Can you find the distance between them? All right, and then what did you do to find that? Well, ideally you subtracted those. The distance between them would be 6. To get from 9 to 15, it's 6. It's easy to think about when they're both positive, but typically we're going to have negative values. The process stays the same. When you're looking for the distance, and this is something that you would want to take a note of, if you're looking for the distance between two things, you're going to subtract. Sometimes we'll be doing it with x's, sometimes we'll do it with y's, but if you're looking for a distance, you subtract. Always take your higher one minus your lower one. So in this case, I do 15 minus 9. That'd get me a 6. All right, but when you're doing amplitude, you want half that distance. So then obviously you're going to divide it by 2. So then the amplitude of this graph would be 3 with my made up numbers. All right, let's see if that would work with, okay, let me get rid of my mess. I got kind of messy here. Would it work with the graph that I have right here? Look at what the y value maximum is. This looks like it's at 5. I'm using the scale now. This y value looks like it's -1. If you take the high minus the low, so 5 minus -1, that would be a 6. And so that distance is 6, and half of that distance would be 3. That's a coincidence that the last one I had was that, but all right, so I just made those numbers up. But you can see right here is kind of the middle of the graph, right in through here. And I'm 3 up and 3 down, so it would make sense that 3 is my amplitude. All right, to find amplitude, let's recap. Do it in the Ed puzzle. What are you going to do to find your amplitude? All right, moving on. Let's work on the period. All right, let me get rid of this mess of stuff that I have again. Getting kind of crazy. All right, I'm looking for the period. When you're looking at the period of a graph, is that an X thing or is that a Y thing that I would be concerned about? All right, it's a horizontal thing, the period. How much space horizontally does it take to make a wave? So that would be an X value that I'm concerned about. So now when I'm looking again at my min and max always, so I'm going to have this value, and I could do any value. I could do this one and this one, whatever it takes. Any of the mins or maxes. To find the period, I want to know the X value. I want to know the distance that it takes to make a full wave. Now, if you will recall, a sine wave looks like this. You start in the middle and you all the way up, all the way down, and back to the middle. The problem with looking at our sine wave that way is I can't very easily find the middle of these waves. It's not going to come out pretty, and so I can't just guess at where the middle is. So what we have to remember is it doesn't really matter. To find a period, you're just finding from one matching spot to its next matching spot. So I could go from middle to middle. That would be fine. I could go from here to here. That'd be a period. I could also go from a peak to another peak. Or I could go from a valley to another valley. Whatever it is, as long as it's a matching set part of the graph, that would create one period. So what I'm going to do is I'm going to look at peaks or valleys. I guess specifically I'll look at peaks here today. So I'm going to look at the peaks and see how far it is to get from one peak to the next peak, and that would be one period. All right, so then let me ask you, if I'm looking for the distance that it takes to get from one peak to the next peak, what do you suppose I'm going to have to do? All right. I hope you said that it's distance, so you're going to subtract. And we had said previously that this is a horizontal thing. It's an x thing, so I should be subtracting my x's. All right, always take your bigger X minus your small x. So when I'm tracing this, I'm going to look for this ordered pair and this ordered pair, and I'll take this X value and subtract that X value, and then I will have that distance right there. Okay, so this is what you want to jot down to find the period. That is the distance from one peak to the next. We already said that when we're doing a distance, we're going to subtract, so I don't think we need to say it again. Oh, distance from one peak to the next. Maybe make a note to yourself that that's an X value that you're looking at. Up here on amplitude, maybe make a note to yourself that's a Y value that you're dealing with. Now, I don't want you to get crazy with notes. I don't want you to be dependent on notes. I just want it to kind of make sense, the process, why you would be doing these things. If you get too caught up in formulas and you lose track of what's going on in the process. Okay, I'm moving on to phase shift. Sorry. Okay, here we go. Phase shift. All right, now phase shift, if you will recall, is how far you have to shift the graph over from where it starts. So a sine wave typically starts at 0, headed up, and looks like this. This is your nice parent one, right? But we've already acknowledged this isn't going to be a parent graph. It's going to be uglier. It's not going to be lucky enough that I just happen to start at 0, 0. When I collect my data, the sine wave is going to be at any point within that wave, and so I'm going to be more inclined to see something like this. Oh, that's not good. Let me try again. It's going to look like that. And because it's going to be, the x-axis is going to be representing time, I'm really not even going to see this because I can't go into negative time. So I'm only going to see this much of it. And so it's going to randomly start somewhere along that wave, and so there's going to be some phase shift. So I have to find the first place along there where I am at 0 headed up, because that's what sine is supposed to do. So I'm going to track that thing and find where's the first place I'm at 0 headed up. And that would be, I don't know, like right here, let's say. I guess I could be using the graph I have up here. Here, the first place I'm at 0 headed up looks like it's about here-ish or something. At 0 headed up. All right. Now the problem that I have here is that this is in the middle of the graph. Remember, I can't, if I were to trace this, more than likely it would sit there and go from here and here and here and here, and it would hop over the spot, the exact spot I want. So I can't trace it to find this ordered pair. I have to find that ordered pair a different way. Now, before we get too far, let's talk about phase shift. Does that seem like that would be a horizontal thing where you'd be looking at your x's? Or is that a vertical thing where you'd be looking at the y's? All right, phase shift is how far it's moving left and right. It is definitely an x value that you're looking at. So I would like to know the x value of this point right here, but I can't find it. So there's got to be another way that I can get to it from the peaks and the valleys. So think about this for a minute. If I knew this ordered pair right here, and I knew this ordered pair right here, how am I going to get to this point right here? Now, we've already discussed, I really only care about the x's right now. I don't care about the y's. How could I find this x value? All right, so we're doing something different on this one, okay? Instead of finding a distance, yes, I'm looking for, I'm looking for a distance ultimately, but the problem is that to find the distance between the thing that I want, I need to know what this point is. So here's another option. Instead of doing distance, another way that we're going to be working on this lab is to find the middle of something. So if I'm looking for the middle, think about this for a minute with me. If I want the middle of these two blue points, because I know those ordered pairs, and now I'm looking at my x values. To find the middle of these two x values, and even in this graph, these are not pretty, so let me just make up some fake numbers. Let's say that this x value is, I don't know, let's make it a 2. Let's make this x value, I don't know, a 7. How do I find the middle between a 2 and a 7? Because this would have the x value that falls between those. Wouldn't that just be the midpoint of 2 and a 7? If I find the middle of them, that would be the midpoint. And if you remember your midpoint formula, that you're going to add and then divide by 2. Add the two numbers, you're ultimately finding an average. Add them, divide by 2. You're finding the average of them, the middle of them. So if these two, if I had a 2 and a 7, I'd add them, get 9, divide by 2. This x value would then have to be at 4.5 because it's in the middle of 2 and a 7. All right, we're not going to have nice, pretty numbers like 2 and 7. They're going to be ugly decimals, but that process would be the same. So if I want to know what this x value is, I would have to be able to know how far to shift it to the right. Now notice I'm shifting it to the right. So once I could find that x value right there, I would have to remember that's my c value for my phase shift, and I would be subtracting because I'm moving to the right. So be careful when you write your equation. All right, so I'm going to go ahead and jot down a little hint. So if I'm doing phase shift, I'm going to find the middle, and I guess I'll say x value here, the middle x value between the min and the max, to get to that first spot where I'm at 0 headed up. Now I have a quick little hint to you. Be careful that you don't go looking for this spot. Oops, this spot here. Because there I'm at the middle headed down. That's not what I want. I want to be at the middle headed up. So make sure you pick the correct min and max so that that would happen. All right, one more thing. Golly, this is a mess. Sorry. Okay, let me erase some more. Now I'm trying to figure out the vertical displacement. Let's go to the Edpuzzle real quick. Vertical displacement. Will that be an X thing that I'm looking at, or is that a Y thing that I'm looking at for vertical displacement? All right, keyword would be vertical, so that should be something along the Y that I'm looking at. So I'm going to look at Y values. Now your vertical displacement, I'm going to go back to the mins and maxes. Those are the only ordered pairs I have. My vertical displacement is how far the graph shifted up or shifted down. And ultimately, the vertical displacement goes right through the middle of the graph. We call it the equilibrium. It's the equilibrium of your graph. So I got to find the middle of the graph because I know that that's going to be my equilibrium, and that's how much my graph would have shifted to get off of the x-axis. All right, so if I'm looking for the middle of these ordered pairs right here, all right, why don't you make a guess at what you think I need to be doing? Answer in the Edpuzzle. All right, hopefully you tied it all together there. I'm looking for the middle, so that means I'm doing the add and then divide by 2. And I'm doing the y values because vertical displacement has to do with the y's. So now I'm going to go back over here. So I'm going to find the middle. This time I'm doing the y values. Between min and max. Now, I've kind of written out this out for you to kind of like make it stick in your head, but I'd like you to try without well, it's okay to cheat a little bit at the beginning, but by the time you've done this 3 times, you should not be looking at notes anymore because you're not going to look at them on your test. So the key thing is, first of all, you're going to decide, are you concerned about something horizontally and you're looking at X's, or you're looking at something vertically, so you use the Y's? That's the first question to yourself. The next question is to decide if you're doing a distance. Are you looking for the distance between something? If that's the case, then you're going to subtract your values. Or you're looking for the middle of something. If that's the case, you're going to add and divide by 2. You're going to end up using the same ordered pairs a whole lot. So it's going to be nice that you're probably going to want to jot some numbers down when you're doing your lab. We'll talk about that tomorrow. All right, so I have one last thing that we're going to do. Let's practice it. I got the same graph. I know the numbers are nice. On your lab, they won't be, but let's go through the process one time here. So I'm going to go find those key information that we were talking about, and then I'm going to turn them into an A, B, C, and D. All right, I'm going to go with this minimum right here and this maximum right here. I'm going to make up some numbers that seem reasonable for this, but don't get too caught up into them being nice. I'm going to pretend that I'm over, let's say I'm over 0.6 right there, and I am at -1. I'm going to call that ordered pair. This ordered pair, I'm going to say that I am over 1.4. And then I am up 5 units. All right, so let's go through the process. Amplitude. Amplitude is half the distance between the min and max. Since you're looking for distance, what should I be doing? Well, no, backtrack. Half the distance between min and max. Am I looking at X's or Y's? Answer in the ed puzzle. All right, I should be looking at Y's. Amplitude is a vertical concern. And now, am I going to be doing the subtraction because it's a distance, or am I going to be doing add the 2, divide by 2? All right, it's a distance. I am going to be subtracting. I'm going to take my Y's and subtract them. So I'm going to do 5 minus -1. I got a little ahead of myself putting the A, B, C, D there. So the amplitude, I would take 5 minus -1. That's a 6. And I'm going to divide it by 2 because the amplitude is half that. So I know that the amplitude is 3. All right, let's talk about the period. All right, period. Think about what's going on. Your first thing you're going to do is talk about whether you're looking at a horizontal concern or a vertical concern. And then you have to decide, are you doing a distance or are you doing a midpoint for the period? Answer in the ed puzzle what you think we should do. Period is an X concern. It's a horizontal thing. It's how wide the graph is to make one wave. You're looking at X's. And to find the period, you're looking for from the distance from one peak to the next peak. All right, now I didn't put another peak. Let's make one more point. I need another peak. Let's pretend that one is over, I don't know, let's make it be, it looks kind of nice. We'll say it went over 3 and up 5. How about that? All right, so then I need to know the distance between those two, and we're looking at the X's. So to find the period, you're going to take the X, the farther out X, and I'm going to subtract the further in X. That's going to be the period. So 3.1.4 is a 1.6. I now know that the period is 1.6. Does that mean that your B value is 1.6? Nope. What am I going to do to find the period? All right, you got to do the formula. The period, which is 1.6, is equal to 2 pi over B. Go solve for B. You go solve for B. Tell me what you get. You should have gotten a 3.93 for that. Now let's keep moving. Let's go find the C value. C is going to be part of our phase shift. So if you look at what we've been doing all along with phase shift, think about, is that an X value or is that a Y value? And then for the way that we did phase shift, would we be doing a distance or a midpoint? Okay, phase shift is definitely a horizontal thing. I'm looking at X values. I'm looking at where's the first place that I'm at 0 headed up. And that would be, we decided somewhere like right here on our graph is at the first place we're at 0 headed up. I need to know that X value so I know how far to shift. That X value is the midpoint between the peak and the valley. But I'm looking at only the X's. That's all I care about here. So I'm going to find the midpoint. So answer in the Edpuzzle what you think you would have to do here. All right, hopefully you found the midpoint of your X's. It's a 1.4 plus a 0.6 divided by 2. Oh, that came out very pretty. That's 2 divided by 2, so that's 1. So our phase shift is 1. Our C value would be a 1. And when we write it, since we're moving to the right, we would put a -1 when we write that equation. All right, last one, let's do vertical displacement. What do you think I need to do? I'll let you answer in the Edpuzzle. Think about if it's X's or if it's Y's, if it's midpoint or distance. Okay, vertical displacement, definitely a Y value thing. You're dealing with the up and down motion of this graph. And then the vertical displacement is kind of like the middle of the graph. It's kind of like the equilibrium of it. It goes right here through the middle of your waves. Okay, to find that equilibrium, it's going to go through the middle spot of that wave. And so I'm looking for that dot again, except that we're looking for the Y's. So I'm going to find the middle of the Y's, and I'm using those same 2 points. So 5 plus -1 divided by 2. That's 4 divided by 2, which is just 2. So my vertical displacement, it's moving up 2. Then you're going to take all those numbers you just found, plug them into your equation over here. You're going to type it into y equals, and then you're going to cross your fingers that your equation matches your data that you collected from the tuning fork. That's our goal. And we need to be efficient enough at it that it makes sense and that we can do it multiple times relatively quickly. All right. Hope you're ready. We need to hit the ground running tomorrow, so let's do it.